Okay, in this video, we're going to start talking about Module 12, bonding and structure. Before we start learning new things, I want to emphasize that a lot of information in this module are based upon very, very complicated mathematics theory and physical theory. So we're just touching base with you guys about some basic atomic and electron structure of elements for single atoms. Okay, um, you will be learning a lot of basic principles, and we want to see if we can apply these principles to what we have learned before about elements and compounds and that kind of thing. Okay, so just bear that in mind. Before we learn the new things, let's recapture what we learned before about atomic structure. So basically, we believe that uh, there's a nucleus, okay, which you'll find the positive charge, the protons, and the neutral, zero charge, the neutrons. In classic chemistry, we are more interested in those tiny particles, they're so-called electrons. Okay, they're usually normally equal number of protons and the electrons, so the overall charge of the atom is going to be neutral. Now, the electrons are usually considered to be very tiny even compared to protons and neutrons, but they are traveling on a certain kind of orbits around nucleus. They're not random everywhere. So that's what we have learned about all of the atoms. Okay. In this module, we're going to try to see if we can find out more insider information about these orbits. Okay, where exactly are these electrons located are? Um, this is a very what you're looking at right now is a very lousy illustration. Okay, the actual orbits will be a lot more complicated than this. We try to see if we can build up a complete structure around nucleus about where electrons are, how electrons are distributed around the nucleus. That's what we're trying to do here. But still, the information we have learned before are going to be quite useful. For instance, these orbits, okay, we have learned that there's certain pattern we know there are only certain number of electrons can be located on these orbits. Starting from the inner layers, okay, if there are multiple layers going outer and outer. So there's a number 2A2, which indicates that there are only two electrons will be allowed, maximum two electrons allowed on the first layer, which is the one nearest to the nucleus, and there will be 8 electrons allowed maximum on the second layer, and then there will be 8 more electrons allowed on the third layer, and then 2 more electrons allowed on the fourth layer. And based upon that, we developed into inner electrons and the valence electrons, and then we learn the optical rule based on that. So that's what we have learned. Okay. Now, what we're trying to learn next is I've summarized the next few slides into a few simplified version of slides. Okay. Now, what we just talked about, those orbits, those circles. Okay. Let's look at it again. Okay. These circles. Okay. We believe there's a certain number of there's a certain number of electrons can be located on these circuits. Okay. We call these circuits principal energy levels. Now, principal energy levels usually will be indicated by a number. We usually give a symbol to this number to be n. This n is not the same n as in the n in the gas law. Okay, this n can be only integer numbers 1, 2, 3, 4, and so on. Now, these numbers goes from inner layer to outer layer. The larger this number is, that means the further away from the nucleus. So you can imagine the size goes bigger and bigger. Okay. Not only that, size-wise, it goes bigger and bigger, radius, and as well as energy. So electrons located on the lower number n, like first or second layer, in generally considered to be lower energy than the electrons on the third or fourth layers, and it goes on. Okay. Just a reminder. Okay, we have learned that these integer numbers also correspond to the period number on the period table. We'll talk about that a little bit more in detail later on. Okay, so we understand the principal energy level. Okay, now within each principal energy level, this is something new. There are actually something called sublevels. Okay, or called orbitals. Now, what are these orbitals? Usually, these orbitals will be indicated by a letter. There are only four kinds of sublevels or orbitals we have found in this universe. They are S sublevel, D sublevel, I'm sorry, P sublevel, and D sublevel, and F sublevel. There's something you want to know about these four sublevels. First of all, there are only four kinds of them. Okay, the difference between them is shape. We'll talk about that later on. Okay, why they're different. So different alphabet letters here indicate different shape of the orbitals. Second of all, energy. In general, okay, we believe that as long as you're located on the same principal energy level, then the S sublevel would have the lowest energy than everybody else. P would be the second lowest one, and D would be the second highest one. The S sublevel usually believed to have the highest energy compared to the rest of the sublevels. Again, we're talking about within the same N value here. Sidewise, since they are in different shapes, so it's hard to compare whether they are bigger or smaller than the other ones, but obviously they all have different sizes. Okay. And the most important thing is number of orbitals. Now, within each sublevel, or let's say these four letters indicate different sublevels as well as different kind of orbitals. So there is only one orbital at S sublevel. There are three orbitals in any P sublevel or P orbital. There are 5 orbitals in D sublevel or D orbitals, and there are 7 orbitals in F sublevel. So this is probably one of the most important things you want to know. Okay, there's different number of orbitals within each sublevel, and then one more thing, each orbital will contain certain number of electrons. How many? Up to 2 electrons. You can have it empty, so there's no electron in it, or you can have 1 electron in it, but you can't have more than 2 electrons. You can have 2 electrons in each one orbital. So in other words, if you're looking at the S sublevel or S orbital, there's only one orbital, and this orbital can hold up 2 electrons, which means you can hold up to 2 electrons. If you have 3 orbitals in P, then your maximum capacity will be 6 electrons. If you have 5 orbitals like in D, you can have up to 10 electrons. If you have 7 orbitals like in F, you would have up to 14 electrons capacity. Again, we're talking about up to, okay, capacity here. They can be empty, they can be half empty, you can have any number as long as it doesn't go above these numbers. Okay, so based upon these, we can start building up how electrons likely to be distributed around the atoms. Okay, so let's start from the first principal energy level. In the first principal energy level, n equals to 1, and it can only contain one sublevel, which is 1s. And usually this is how you show it. You have n value here, okay, which shows the principal level, and you have an alphabet letter to show you, followed by alphabet letter shows you the sublevel. Okay, but in the first principal energy level, there's no other possibility, just 1s. That's it. There's no P or D or F. When n equals to 2, you can have 2s sublevel or 2s orbital and 2p orbital, but nothing else. In the third principal energy level, you can have 3s and 3p and 3d, 3 sublevels. In the fourth principal energy level, you can have 4s, 4p, 4d, 4f. It seems like it's building up more sublevels as the n number goes higher and higher. Once you get above 4, starting 5, you would have the same sets of sublevel or orbitals, the same as 6. If you want, you can continue and 7s and continue like that. So when you look at this, this is basically a complete map of for all of the atoms, starting from 1s, 2s, 2p, 3s, 3p. Keep in mind, okay, a couple of things here. When the n number goes higher and higher, the energy goes higher. Okay. Now within the same level, from left to right, the energy goes higher as well. Not only that, each orbital has different capacity. Now usually we would put a little number on top to indicate how many electrons are in this sublevel. Now let's say the maximum number, okay? I mean, when you have different number of electrons as different atoms does, they would fill in this orbitals differently, okay? You would have the maximum capacity for 1s is going to be 2 electrons. For the maximum number of electrons for 2s is going to be 2 as well, because there's only one, keep in mind, there's only one orbital. You can remember they're going up by odd numbers, 1, 3, 5, 7. And multiply each number by 2, that will be how many electrons can be held by each orbital, each sublevel, I'm sorry. So 2p will be able to hold up to 6 electrons. And 3s will be able to hold up to 2 electrons as well. And 3p will be able to hold up to 6 electrons. And 3d will be able to hold up 10 electrons. And goes on like this. 4s, just like 2s, 3s, 2s, 1s, will hold up 2 electrons. 4p will be holding up to 6 electrons. 4d will be holding up 10 electrons. 4f will be holding up 14 electrons. And then this 2, 6, 10, 14, and 2, 6, and 2, 6. So you can see, depends on how many electrons you have, you start filling this in the order of energy, and if for each atom would have different distribution of electrons, we actually call this electron configuration. Okay. So this is the introduction for the electron configuration we would like to start with.